So, to defy, in my own understanding, the field of strength of materials deals with forces and deformation that results from their acting on a material. This is most often learned by the first studying the what you call a quasi-static elastic beam theory, which is the one-dimensional deformation of a homogeneous and orthotropic material, such as steel essentially for loadings. You then moved on to dynamic loads and deformations, and plate, and also the shell theory, with additional dimension. Finally, you consider the plastic, brittle, and other non-elastic behaviors. All of this is essential for aeronautical engineers who must be able to mathematically specify behavior of materials in their design. Strength of materials is a fundamental subject needed primarily for aeronautical science, as the aeronautical engineers' designs of different components and structures used in practice are done using different kinds of materials. The material that is used in aircraft and also on aerospace. Perhaps it deals with firstly with the effect of machining technology on structure of aircraft material. We all know that aircraft materials should ensure structural strength when exposed to heavy power loads, high or low up temperatures and corrosive environments. Also some like electromagnetic radiation, X-ray radiation. And in addition, their specific weight should be, should be minimum. It is rare to find at least one material which possesses all the properties needed for manufacturing airframe and engine. To achieve the balance between cost, performance, and safety, the combination of strength of materials is needed. There are large differences between performance and the cost of materials. For example, aluminum and steel are the least expensive materials. Composites are the lightest materials. Steels have the highest stiffness and the greatest strength. And nickel alloys have the best mechanical properties at high temperature. Therefore, airplanes and engines are manufactured using a variety of materials. They use environment for airframes and engine components, predetermined stringent requirements for aircraft materials. An example would be a machining of metals. Milling is a common machining operation that involves the use of multi-tooth cutter to remove metal from the surface in order to create flat and angular surfaces and grooves. Due to their complex shape, special materials, and low stiffness, the aviation parts are difficult to machine. Typical aviation parts are spars, ribs, skins, panels, brackets, and etc. The main material used are aluminum, titanium, and alloyed steel. What pieces machines are blocks, foldings, stampings, and castings. Only some parts have shapes which are close to the target ones. A small amount of materials, less than 5% of weight, has to always be removed. The next example is the stress transformation, which are results of simple equilibrium. However, they can be represented with the equation of a circle known as Morse circle, where the stresses in the x and y direction represent the rotated coordinates frame. Sigma is the average normal stress on the original xy coordinate frame, which is determined through trigonometry using the 2 points on the Morse circle defined by the known stress state in the x and y coordinate frame. One of the main applications of stress transformation relates to the application of failure criteria. Although numerous failure criteria exist, for this course we will only focus on the yield criterion, which is given by the Tmax. So in conclusion, strength of materials is an important factor for aeronautical engineering. Thank you.